This video is going to have a look at solving simultaneous equations algebraically using the elimination method. So by the end of the video, you will be able to apply the algebraic method of elimination to solve a simultaneous equation. So when we are solving simultaneous equations algebraically, we have got two methods that we can use. We can use substitution or we can use elimination. This video is going to have a look at the elimination method. So when we are using elimination, the first step is to write the equations underneath each other and then select one variable that can be eliminated. Once we have eliminated or selected that variable that can be eliminated, we want to combine and simplify the equations by either adding or subtracting each side together. Then you can solve the equation to find the missing variable. And then after we've got one known variable, we can substitute into an original equation to find the second unknown variable and then write your answer. So let's have a look at some practical examples of how we can apply these steps to solve a simultaneous equation using elimination. So in the first example, we have got 3x plus y is equal to 5, and we've got 5x minus y is equal to 2. So we're going to write those equations underneath each other. So we've got 3x plus y is equal to 5 and 4x minus y is equal to 2. And we want to look for a variable that can be eliminated if we were to combine those two equations together. So having a look, I've got a plus y and I've got a minus y. If I combine those two equations together, those y's are going to cancel each other out. So I can select y as my variable that can be eliminated. Now, sometimes you might need to make some adjustments to one of the equations to get to a point where you've got a variable that can be eliminated. But in this case, we've got a plus y and a negative y, so we don't need to go through and make any adjustments. So now that we've selected our variable, we can combine the equations together by adding or subtracting. So because I've got different signs in front of the variables, I'm going to add them together. So combining the two together, it's going to be 3x plus y and then plus 4x plus negative y. So I've added my left-hand side together. I also need to add my right-hand side together. So 5 plus 2. So simplifying my equation that I've created by adding my two simultaneous equations together, I'm going to have 7x is equal to 7. Because when I have combined the equations, my plus y and my negative y have been eliminated. So that leaves them with 3x plus 4x, which is equal to 7x. 5 plus 2 is equal to 7. So now I can solve and find a value for x. So if 7x is equal to 7, then x is going to equal to 7 divided by 7, which is equal to 1. So now that I've got a value for x, I can substitute it into an original equation to find a value for y. So I've selected 3x plus y is equal to 5, but you can select either of the original equations. So substituting in my value for x, 3 times 1 plus y is equal to 5. So 3 plus y is equal to 5. So y is going to be equal to 2. So now that I've got a value for x and a value for y, I can go ahead and write my solution. So x is going to equal to 1, y is going to equal to 2. So that's an example of how we can solve simultaneous equations using the elimination method. So let's go and have a look at a second example. In the second example, I have 2a plus b is equal to 7 and a plus b is equal to 5. So I'm going to start off by writing the two equations underneath each other and look for a variable that might be able to be eliminated. So having a look, I have got a plus b and a plus b in both of my equations. So that is the variable that I can have a look to be eliminated. And I'm going to eliminate them by combining the two expressions together. This time, unlike the first example, I've got a variable that has the same sign in front. So plus b and plus b. So I'm going to subtract my equations. So I'm going to start off with 2a plus 2b. Then I'm going to subtract a and subtract b. And that's going to equal to 7 minus b. So when I go ahead and simplify, my plus b and my minus b are going to be eliminated, and 2a minus a leaves me with 1a. So a is going to equal to 2. So I don't need to go ahead and solve to find my missing variable, because when I've simplified the equation, it has done that for me. So now I can substitute in my a equals 2 value into an original equation. So I've selected a plus b is equal to 5. So 2 plus b is equal to 5. So b is going to equal to 3. So I can go ahead and write my answer. A is equal to 2 and b is equal to 3. So let's have a look at the third example. I've got 3c plus 4d is equal to 5, and 2c plus 3d is equal to 4, and I want to go ahead and solve those simultaneous equations. So writing the equations underneath each other, I've got 3c plus 4d and 2c plus 3d. Now I want to be able to come up with a solution where I can eliminate one of those variables, but at the moment I don't have a variable that can easily be eliminated. So I've got to go through and make some adjustments. So I've got 3c and 2c. So I need to go ahead and make some adjustments to them. So I've got the same variable in front of them. And I can do that by coming up with a common multiple of 3 and 2, which is going to be 6. So my first equation, I want to multiply by 2. And that's going to get me 6c plus 8d equals 10, because I multiply all my terms by 2. And for the second equation, I'm going to multiply all my terms by 3. So multiplying 2c by 3, multiplying 3d by 3, and 4 times 3 gets me 6c plus 9d equals 12. And now I've got a variable which I can eliminate. So I can go ahead and combine my two equations together. And because I've got the same variable in front, I am going to subtract them. So it's going to be 6c plus 8d minus 6c minus 9d is equal to 10 minus 12. So now I've got my c's that when I simplify my equation are going to be eliminated. So that leaves them with 8d minus 9d. So negative d is equal to negative 2. So I can find a value for d. I know that negative d is equal to negative 2. If I divide both sides by negative 1, that is going to leave me with d is equal to 2. Because I don't want a negative d, I want a positive d for my value. So now that I know the positive d is equal to 2, I can substitute that value into an original equation. So 3c plus 4d is equal to 5. So when I substitute my d equal 2 into that equation, it is going to be 3c plus 4 times 2 is equal to 5. So 3c plus 8 is equal to 5. 3c is equal to negative 3 over 3. So c is going to equal to negative 1. So now that I've got a value for c and a value for d, I can write my final answer. So c is equal to negative 1 and d is equal to 2. So that's some examples of how I can solve simultaneous equation using the elimination method instead of the substitution method.